we witnessed how to create the tables, views, inserting rows, how to insert rows, how to delete, how to update, how to modify. This is what we discussed about the DDL commands, DML commands, and we discussed about ER diagram stands for entity relationship diagrams. ER diagram stands for entity relationship diagrams. This is what we learned in our previous classes. Now we discuss about the relational algebra. Present we are working with a lot many softwares, the database softwares. And coming to the database softwares like SQL, Oracle, MySQL, Ingres, Paradox, Informix, SQL servers, Mongo database, Elastic databases, Debian. We are working with many databases, Firebase. For these databases, the background is mathematics. The backdrop of these databases is nothing but it is a mathematics. In mathematics, you are having a concept of relational algebra. It is totally the mathematical concepts based on these mathematical concepts. Based on these mathematical concepts, the present modern softwares are being designed. Before going to that, let us have a recap of the previous discussions, the previous class discussions, and then we go ahead with the relational algebra. In the previous class, we had a discussion on views. A view is a logical window which is focused on the base table. This is what we discussed. You're having physical level, logical level, and view level. When you're talking about the data abstraction, there are three levels of the data abstraction. One is called the physical level, next is logical level, the third one is view level. How the data is recorded is nothing but the physical level. What data is recorded is logical level, and what is seen is nothing but view level. We may store a lot of data, but all the data which we are storing is not visible. The data what you stored is nothing but the logical level or the conceptual level, and the data what you are visualized to see, what you are visualizing is nothing but the view level. What data is recorded is nothing but it is a logical level, and what is seen, all the recorded data is not visible, only the required data is visible, that is nothing but the view level. So you are having three levels, one is physical level, logical level, and view level. These are the three levels. And coming to the view level, we create some views on the base table. A base table is the actual table. The actual table is nothing but the base table. On the base table, we create some views. The views are being created on the base table. A view is logical. Based on some criteria, using some certain conditions, we create a view. And if you peep through that view, only the rows which are satisfying those conditions are visualized. For example, in a organization, there is a 10th department, 20th department, 30th department employees. There are maybe 1,000 employees in an organization. The 1,000 employees are being grouped under 10th department, 20th department, and 30th department. Now for the department manager of 10th department, he need to visualize only 10th department employees. He is least bothered about 20th department employees and 30th department employees. Whenever he sees the base table, then he should see only 10th department employees, not 20 and 30. Then I'll create a view. Then I create a view on the base table. So through that view, only the 10th department employees can be visualized. If I create a view for 20th department employees, through that view, you can visualize only 20th department employees. Rest of the employees are not seen. That is nothing but it is a view. Views provide security. It provides data independency and it provides security. A lot of security can be provided. Confidentiality can be maintained. Only the required rows can be projected and rest of the rows can be kept hidden. The confidentiality can be provided. Views can be updated. You can update the view. If at all you want to do some modifications to the view, you can do modifications to the view. You can update the view. You can delete the view. So views are updatable. Any modifications I can do that. And in views, I make use of check option, with check option. There is an option called with check option. What is this with check option? For example, I'm working with the 10th department view. From that view, I can visualize only the 10th department employees. The rest of the employees are not visible. Fine. From the view, I can insert all the 10th department details. Yes, it is possible. From the view, I can insert all the 10th department employees. It is possible. But here the problem, what the problem is, From the view which is intended for creation of 10th department, if I insert the employees of 30th department, they also get inserted. I created a view for 10th department. From that, I can see only 10th department employees. I can insert 10th department employees. I can update 10th department employees. But now the problem is with the view from the 10th department, if I insert 30th department employee, it inserts into the base table. The view of 10th department will accept the 30th department employees data and it puts in the base table. I should not entertain such things. It should work exclusively for the 10th department employees. No insertion and deletions of or updations of 30th department employees or 20th department employees. To prevent that, I go with check option. I just go ahead with the check option. With the help of check option, you can prevent that. Only intended records can be inserted, deleted or updated, and unwanted records cannot be entertained by that view. That is the purpose of with check option. You can, if the base table is removed, views will not work. If base table is removed, views will not work. There is a command called cascade. There is a command called cascade, which is used with the drop table command. If you use a drop table, base table name, cascade option, drop table, base table name, cascade option, when base table is removed, automatically its dependent views also will be removed. The purpose of cascade option with a drop table command is, if the base table is dropped, if the base table is removed, automatically its dependent views also will be deleted. That is the advantage of cascade. If I want to remove view, I can remove view. If I want to remove base table, I can remove base table. But if base table is removed, views will not work out. And remember, I can rename the base table. When the base table is renamed, view will not work. If any disturbances happens on the base table, it reflects on the view. A view does not contain data. It extracts the data from the base table. It is a logical window which is focused on the base table. It takes the rows from the base table. It inserts the rows into the base table. It deletes the rows from the base table. A view is attached to the base table. Whatever transactions you do to the view, it affects the base table. If base table is removed, finish, view will not work. If base table is renamed, view will not work. If base table is altered, it affects the view. So these are the points what we discussed in our last class. And now let us go ahead with the next topic. In this class, let us have a discussion on relational algebra. It is a mathematical concept which is used regularly in the field of computer science. Unary and binary algebra, selection operation, projection operation. Selection operation with logical operators, and of course the projection operation, and the combination of selection and projection and mixed fragmentation. In this class, we are going to discuss about relational algebra, unary and binary algebra, selection operation, selection with logical operators, projection operation, and the combination of selection and projection, mixed fragmentation, and some practice queries. These should be the outcomes of today's class. Let us proceed. Relational algebra. Dear students, be alert. Relational algebra. The present day we are working with Oracle. You might have listened about Oracle, SQL, structured query language. You might have heard about SQL, MySQL. You might have heard about SQL servers. And present day we are working with the Mongo database, Elastic databases, Mongo database, Elastic databases. And of course, previous days we worked with the Ingres Paradox. All these are the database softwares which are developed based on the mathematical concepts of relational algebra. In mathematics, there is a concept of relational algebra. Based on the principles of relational algebra, many softwares are being constructed, and SQL is one such software which is taking the mathematical concepts as a foundation. Now, in this class, we are going to talk about relational algebra. We are going to discuss about relational algebra. It's a very simple concepts. Relational algebra. The inputs and outputs of queries are relations. We take tables, a tabular representations. We give input as a table and you get output as a table. The input is in the form of a table form. A relation means in the form of a table. And after querying, after processing the query, you get an output, which is also in a tabular representation. Input is tabular representation and its corresponding output is also in the tabular representations. The inputs and outputs are the queries are relations. Of the queries are relations. Relations are nothing but it's a table representations, that is the rows and column representations. The query is evaluated using instances of each input relation and it produces the instances of output relation. Instances is nothing but data. Instances is nothing but data. So an input table contains some data. The data is being processed. That instance is nothing but the data. The data is processed of the input relation and it gives an output data which is an output relation. The instances of each input relation, that is the data of input relation, is being processed and you get the instance, that is again you get back the data of output relation. Input is data, output is also data. Input is relation, output is also a relation. In defining relational algebra, the alternatives of referring to fields by position is more convenient than referring the fields by name. Here the positional representation is important, it is more convenient than the field names. That is, if a table is having first field, second field, third field, for example student number, the table is having some fields like student number, this is a field. It is having student number. It is having a field like name. It is having a field like name. It is having a field like total. It is having a field like total. Total is a field. Now, this student number is a name is a name, field names. These are all field names. Student number is a field name is a field name, total is a field name. Or they can be represented by positions. This is the first position, this is second position, this is third position. If I say second field, that is nothing but name. If I say third field, that is nothing but total. If I say first field, that is nothing but student number. You can represent in relational algebra, you can represent either by the positions, that is 1, 2, 3, or by the names, that is student number, name and total. Anything will do. Once again, I repeat, in relational algebra, as per the relational algebra, you can represent either the positional names. This is 1, position 1. If I say 1, 2, 3, 1 means student number, it is implied. 2 means name, 3 means total. So you can represent the positional number or by the field names you can represent this. And coming to the queries are often involve the computation of intermediate results which are themselves the relation instance, and if we use the field names etc and specify the names of fields of all intermediate relation instances. Suppose I want to perform some calculation on a table. The table is a relation. I got some intermediate results. Let me say intermediate results is R2. The starting relation is R1. I got intermediate relation is R2. On R2, that is the intermediate relation, I applied some calculations and I got final result R3. If you observe, our input is a relation, output is a relation, and the intermediate results are also relations. Everything is in the form of relation. Relation means in the form of a table. The input is a relation, the output is in the relation form, and the intermediate result is also in the form of a relation. R2 is in the relation form. R1 is a relation, R2 is a relation, R3 is a relation. Everything is in the form of relations. So this is how, as everything is in the form of relation, that is a table form, it is called relational algebra, and hence it is called as a relational algebra. Input is a relation, output is a relation, intermediate results are relation. Relation means a table in a tabular form, and hence we call it as relational algebra. Now, sample relations. Let us just examine some sample relations. We just examine some sample relations. Listen carefully, we are working with some sample relations. Here there is a relation called S1, or I am calling it as a sailors. S1 is a sailors. S1 is a relation, sailors. The details of sailors is available here. Sailor ID, sailor name, rating and age. Sailor ID, sailor name, rating and age. The details of sailors are here. Just I read out 22, sailor ID is 22, Dustin. The name of the sailor is Dustin. Rating is 7. Depending upon skill, he is given some rating. So his rating is 7 and his age is 45 years. Sailor ID is 31, his name is Lubber. Sailor ID is 31, his name is Lubber. Rating is 8 and age is 55.5. Sailor ID is 58, name is Rusty, rating is 10, rating is 10 and age is 35.0. This is one relation, let me call that relation is S1. The details of sailors are available, these are the instances of sailors. This is called one relation. The name of the relation is S1. There is another relation S2. You observe here, I am showing you different relations as per relational algebra. This is sailor ID, sailor name, rating and age. Again, I am taking sailor ID, sailor name, rating and age. This is another relation. I am calling it as an S2. 28, Lupi. The name of the sailor is Lupi. Rating is 9, age is 35 years. 31, the name is Lubber and rating is 8 and age is 55.5. Sailor ID is 44, Guppy. The sailor name is Guppy. Rating is 5 and age is 35. Sailor ID is 58, name is Rusty and rating is 10, rating is 10 and age is 35 years. This is another relation S2. The data or the instance, the data I am calling it as an instance. The instance which is available in this relation is being depicted and the relation is being said as S2. The name of the relation is S2. The name of this relation is S1. The name of this relation is S2. S2 is the name of the relation. Here I am taking another relation called R1. R1 is another relation. R1 is another relation. R1 is a relation which contains some data, something like this. That is reserves. 22, boat ID, BID is the boat ID. 22, who is 22? The 22 is Dustin. 22 is nothing but Dustin. The Dustin 22, 22 is a Dustin. Sailor ID is a Dustin. 22, he reserved a boat 101 on so and so date. 58, sailor ID is 58. 58 is nothing but Rusty. 58 is nothing but the Rusty. 58, the boat ID is 103. Boat ID is 103 and he reserved a boat on 11/12/1996. Just I am projecting some relations. You observe here, this relation is being depicted as sailor, sailors, sailor ID of integer, sailor ID of integer, name is of string, rating is integer and age is real number, 55.5 and real number. For example, you take reserves. The reserves contains, this is the table, reserves. This is the table reserves, which contains sailor ID, which is integer, boat ID is integer, day is of date type. Day is of date type. So you can have the relations which are represented in this form. Boats, reserves, students, college, employee, and so on, so on, so on. You can represent the relations in relational algebra like this in a tabular form. S1 is one table representing sailors. S2 is another table which is also representing sailors. R1 is a table which is representing reserves. Just 1 minute. You please go through these three relations and what I wrote here. Of course, the boat table I hadn't specified here. We specified in this slide, you can witness sailors table and you can see the reserves table. These are sailor table and this is the reserves table. Of course, the boat table is not placed here. Just 1 minute. You have a glance on this. Right? Now, let us go ahead with the operations. Operations, what we perform on this. Relational algebra. Relational algebra. Slowly, relational algebra concepts are being applied on those relations. In the previous slide, you witnessed the sailor's table, boat table, and reserves table. On those relations, we will be applying relational algebra concepts. Relational algebra is one of the two formal query languages, that is relational algebra and calculus. You are having two languages, mathematical languages. The two languages are algebra and calculus. And relational algebra is one of the mathematical language. The two languages are popular languages which works on data are algebra and calculus, and relational algebra is one of the language. The query in relational algebra are composed using collection of operators. We use various operators while writing the query in relational algebra like greater than symbol, less than symbol, greater than or equals to, not equals to, less than or equal to, double equal to, and all these. Apart from that, we also make use of logical operators like AND operator, OR operator, NOT operator to extract the data. So, the queries in relational algebra are composed of collection of operators. We make use of various operators. The queries in relational algebra are composed of various operators. The fundamental properties is that every operator in relational algebra accepts one or two relational instances as arguments and returns relations It takes relations, it works on relations, and the output also will be a relation. The input is a relation, means in the form of rows and columns. The output obtained is also in the form of a relation, that is in the form of rows and columns. Input is relations and output is a relation. A unary algebra operator applied on a single expression, whereas a binary algebra operator applies on two expressions, more than one expression. That is a binary algebra. I can make use of a single expression, or I can go with the multiple expressions, or with the help of logical operators, can go with more than one expression. That is a binary algebra. Binary algebra operator applied on two expressions, whereas unary algebra operator applied on single expression. You are having single expressions and multiple expressions. We will work out. We will work out with some examples. I will demonstrate some examples. So for time being, you remember you are having a unary algebra operators, that is a single expression operators, and of course binary algebra operators that are more than one expression, that is a two expression operators are there. Each relational query describes the step-by-step procedure for computing the desired answer based on the order in which the operators are applied in the query. So here there is a systematic approach, that is a step-by-step approach to retrieve the result. To get the answer, you hang a systematic step-by-step approach with which you can extract the answer. These are the basic points we need to observe, we need to follow while going ahead with the relational algebra. Now let us go with an operator called selection operator. Listen carefully, I am going with the selection operator. This is selection operator is depicted with the sigma, this symbol. This is called selection operator. It is represented by this symbol. This is called selection operator. The selection operator is depicted with this symbol. This is sigma. This is called selection operator. The sigma operator is nothing but it is called selection operator. The selection operator is used to extract rows, or it is called horizontal fragmentation. It is used to extract the required rows, which is called horizontal fragmentation. Listen carefully. I'm going to ask you some questions. Be alert. Based on my explanation, I'll be asking you questions. I'll be interacting with you. All the students be alert. Relational algebra includes operators to select rows from a relation, select rows from the relation with the help of the symbol, and project columns. What is this project? We will discuss later. First we focus on selection operation, then we go with the projection operation. We go with the selection operation now, and after completion of that we go with the projection operation. Suppose this is the instance. I am calling it as an S2. This instance, this relation, I am calling it as an S2. In this relation, you are having 28 UP, rating is 9, 35 age, 31 Lubber, 8, rating is 8 and 55.5, 44 Guppy, and rating is 5 and age is 35.0, 58 Rusty, the rating is 10 and age is 35.0. This is one relation, I am calling it as an S2. These are all sailors. This is the data of some sailors. Now listen carefully. If I say select, this is the symbol, select. You observe this point carefully, all of you. You observe this point carefully. Select rating greater than 8 from S2. Select rating greater than 8 from S2. The meaning of this is, the output of this is, you get Loopy and Rusty. You get the complete data of UP and Rusty. Why rest of the sailors are not coming? You are saying whose rating is greater than 8 from S2. S2 means this entire relation is called as an S2. From S2, whose rating is greater than 8, select. This is a select. Select only those tuples whose rating is greater than 8. Select only those tuples whose rating is greater than 8. Now if you observe UP, his rating is 9 and hence you got in output. Lubber you are not getting. 8 is greater than 8 is false. Rating is 8. Here my question is greater than 8. This is only 8. It is not greater than 8. So you will not get. Guppy is 5. Rating greater than 8? No. He will not get. Rusty is 10. Rating is 10. Is it greater than 8? Yes. And hence you are getting Rusty in your output. So on this relation, if I use this particular query of relational algebra, select a rating greater than 8 from S2, you get output like this. The output is also a relation. Input is a relation, output is also a relation. You got UP, reason his rating is greater than 8. You got Rusty, reason his rating is greater than 8. And hence you got this relation. This is the output of this. This is what you need to focus. This is called selection operation. Select rating greater than 8. You get all the rows whose rating is greater than 8. So here 28, sailor ID 28 and sailor ID 58. You get the ratings. These two rows only you will get. These two tuples you will get. The reason their rating is greater than 8. Just 1 minute. You focus on this. Please go through this slide. Once, twice. You please go through the slide. Let us go ahead with the next slide. Fine. Let me go ahead with the next slide. You observe here just for practice. Suppose this is S2. From S2 I am saying select age greater than 40 from S2. Age greater than 40. Age greater than 40 from S2. Age greater than 40. Here you are having lot many. Greater than 40 from S2 means from S2. His age is 35. No. Age is 55.5. Yes. Age is 35. No. Age is 35. No. And hence in output you will get only Lubber. In output you are getting only Lubber. This is input. Input is a relation in the form of table. Output is also a relation in the form of table. The query is select, that is sigma, select age greater than 40 from S2. S2 means this is the table. This entire table is called S2. From S2, Age greater than 40. Age greater than 40. So you get those sailors whose age is greater than 40. Here there is only one sailor with age greater than 40. That is 55 years. Lubber with 55 years. 55.5. Lubber with 55.5. Please go through this slide. Okay. You can also use logical operators. AND operator, OR operator you can use. As you know well, the logical operators we use in our programming languages, C language, Python language, we use the logical operator, the less than or equals to, equal to, relational operators. Not equal to, this is a symbol of not equals to, greater than or equals to, OR operator, OR operator. You can use OR operator. This is OR operator and AND operator. This is logical connectivity, logical connectivity. This is AND operator. This is OR operator. You can make use of AND operator, OR operator. And apart from AND or operator, you can make use of less than or equals to, equal to, not equal to, greater than or equals to, or greater than symbol. You can make use of all these operators to check the conditions. Selection with combination of logical operators. Let us go ahead with selection with combination of logical operators. As per relational algebra, suppose this is the table, I am calling it as an S2. This table is being called as an S2. S2 is nothing but this table. This table is called S2. Select rating greater than 5, rating greater than 5, and you observe carefully what I am saying, and select rating greater than 5 and rating less than 10, means the rating which is lying in between 5 and 10 from S2. I want those. I want those sailors whose rating is greater than 5 and I am using AND operator, logical operator, and rating less than 10. Greater than 5 and rating less than 10. You get UP and lubber. Here of course you are having 4 members are there, but in output you are getting only UP and rubber. Why you are getting UP and rubber? Greater than 5 and less than 10, I am saying. Greater than 5 and less than 10. Rating of UP is greater than 5 and less than 10, and hence you got UP. In your output you got UP. Greater than 5 and less than 10, of course you are having lubber, and hence in your output you are getting lubber. Greater than 5, no, this is wrong. Less than 10, no, it is 10. This is also wrong, and hence you are getting these 2 rows only. This is the purpose of selection operation with relational operators greater than, less than, and logical operators and. In this query you can notice the rating greater than 5 and rating less than 10. The greater than symbol and less than symbol are nothing but the relational operators. AND operator is a logical operator. If all conditions are true, result is true. If any one condition is false, everything is false. That is AND operator. If rating greater than 5 and rating less than 10 from S2. Rating greater than 5 and rating less than 10 from S2. So the sailors whose rating is in between 5 and 10, in between 5 and 10 is nothing but UP and lubber. And Guppy and Rusty you will not get. Reason, it is greater than 5 is false. 5 is greater than 5 is false, and hence you will not get. The Rusty also you don't get because 10 is less than 10 is false. You will not get Rusty. This is the output for this query. Students, you please study S2. You please study this query and followed by the output of the query. Yeah, please go through this for a minute. We are discussing about selection operation. Yeah, please ask me.
Sir, what is meant by OP constant, sir?
OP is nothing but operator.
Okay.
Attribute, operator, attribute 1. Rating greater than 5. Operator can be either greater than symbol or less than symbol. You observe here, this is rating is an attribute, 5 is an attribute, greater than is an operator. OP is an operator, right? This is operator, greater than symbol or less than symbol, we use operator. And this is attribute. Rating is an attribute, 5 is a attribute value. So attribute value, operator, this is OP. OP is an operator. We use an operator. Between two attributes, we use an operator. OP is an operator. Any more doubts? Okay, I'm proceeding to the next concept. Selection with logical operators. Already we discussed one more example on selection with logical operators. Suppose this is a relation. S2 is a relation. S2 is a relation. I'm using select rating greater than 5 and age less than 40 from S2. Select rating greater than 5. Rating should be greater than 5 and age should be less than 40. If you observe here, rating is greater than 5 is for UP and age is less than 40 is for UP is satisfying the condition. And here rating is greater than 5. Yes, age less than 50, less than 40 is false. This is not satisfying the condition. You take this rating is greater than 5 is false. Rating is 5. It is not greater than 5. So this is not satisfying. Rating is greater than 5. Rating is greater than 5. Yeah. And age should be less than 40. Less than 40. Yes, this is satisfying. And hence in output you will get this relation. If you apply this relational algebraic expression on this relation, the output of this will be this is the output. You observe here you are getting 28 UP, rating is 9 and age is 35, and 58 rusty, rating is 10 and age is 35.0. So I'm using on multiple attributes. I'm using relational operators greater than, less than. I'm using logical operators and operator. I'm using multiple attributes. This is attribute. Rating is an attribute and age is an attribute. Rating is an attribute. Age is an attribute. On multiple attributes, I'm checking the conditions. Accordingly, I'm getting the output. You take this example. List out whose rating is greater than 8 or operator. He is using or age greater than 40. Rating may be greater than 8 or age can be greater than 40. Any of the conditions. Rating is greater than 8. Yeah, rating is greater than 8. Age is greater than 40 is false, but rating is greater than 8 for UP. Rating is greater than 8. No. Age greater than 40. Yes. 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 And hence lubber is considered. Lubber is considered. And coming to this, rating is greater than 8. False. Age greater than 40 is false. So this is false. And coming to this, rating is greater than 8. Rating is greater than 8. Yes. Or age greater than 40. Age greater than 40 is wrong. Here when you use or operator, if one condition is true, is result is true. And hence you will get output UP, lubber and rusty. UP, lubber and rusty. You are getting the output of UP, lubber and rusty. Here I am using or operator. Here I am using and operator. You observe here. This is AND operator I am using. AND operator means both the conditions should be satisfied. OR operator in the sense any one condition is true. If any one condition is true, the result is true. That is OR operator. This is about the selection operation. It is used for horizontal fragmentation. Means required rows can be filtered and you get it. That is horizontal fragmentation. Only required rows can be pulled out. The rows which are satisfying the condition can be pulled out. That is the purpose of selection operation. Please go through this slide for a minute. Any doubts? So let us proceed to the next concept. This is all about selection operation. Now we go with the projection operation. It is vertical fragmentation. The projection operation is for the vertical fragmentation. I want columns, required columns. I want to project required columns. Then we use the projection operation, which is represented by the pi symbol. The projection operation is represented by pi symbol, this symbol. In relational algebra, for projection operation, we use the pi symbol. You observe here, project S name rating from S2. From S2, I want only names and ratings. I am least bothered about rest. I don't want SID, I don't want age. Vertically you are getting only S names and ratings. You observe here. Vertically you are getting only S names and age ratings. You are not getting age and SID. So you got UP 9, Lubber 8, Guppy 5 and Rusty 10. This is nothing but the vertical fragmentation. You observe here, select, this is the projection operation. Projection operation is depicted with pi symbol. Project, name, S name, rating from S2, within brackets S2. S2 means this entire relation is called as an S2. From S2, you are asking to project only this data, S name and rating, and hence you got only S name and rating. Output, you got only S name and rating. The rest of the columns like the SID and age are kept hidden. You got only this projection. This is called project operation. The projection operation is depicted with the help of this pi symbol. Pi symbol. Please go through this slide for a minute. Any doubts? Right, students, I am proceeding to the next concept. If you don't have any doubts, I just move to the next slide. You observe the next slide. Just an example on projection and selection. I am clubbing projection and selection. This is the clubbing. Select rating greater than 8. Select rating greater than 8 from S2. From S2 rating greater than 8. Greater than 8 means you will get this and this. Select rating greater than 8 from S2. From that project name and rating. From that project S name and rating. So you will get UP and Rusty. In output you are getting only UP and Rusty. This is a combination. I am going with the mixed fragmentation, selection and projection. Once again you listen carefully. I am using select rating greater than 8 from S2. Rating greater than 8 from S2. From S2. S2 means rating greater than 8. So you will get this entire row greater than 8. Rating greater than 8. You will get this entire row. Rest of the rows are filtered. So you are getting only these two rows, that is 28 UP and 58 Rusty. From this I am projecting S name and rating, and you will get only S name, that is UP, Rusty, and their rating 9 and 10. UP, Rusty 9 and 10. You get the output. This is a mixed fragmentation. Here I am using the selection operation. This is nothing but the selection operation, and I am using the projection operation. Selection and projection combination. Please go through this. Just a minute. Please go through it. Right. Let us go with some practice examples. This is the table. Let me name the table. As sales table. All the students, listen carefully. This is the sales table. Sales is a table which is having salesman number. You hang salesman number or SSN, or I call it as SNO. Let me put it as SNO. Salesman number, name, salesman name, gender, age, and sales amount. Let us assume there is a table called sales table. All of you, let us assume there is a table called sales table. I just project for this. There is a sales table which contains 101 Vasu, male, area is north, 50,000 is the sales amount. Gopi, male, north area is north, 80,000 is the sales amount. Padma, female, north, 30,000 is the sales amount. Radha, female, north, 75,000 is the sales amount. And Giri, is male south area. He is working for area south 20,000. Male area is south, and Kumar is male south area 45,000. And Vani is female. Vani female south area 95,000. Rani female south 65,000. Ganesh male east, it is 70,000 sales. And Lata female east 35,000 sales. These are the sales amounts of these sales. This is one relation. This is one relation. I'm calling it as a sales, or you can say as S1, S2, S3. You can give some name. I'm calling it as a sales. Now your question is, list out all salespersons whose sales amount is greater than 50,000. I want a selection operation. He's saying list out all salespersons whose sales amount is greater than 50,000. Now you observe carefully. That is a sales table. Your question is list out all salespersons whose sales amount is greater than 50,000. ఎవరి సేల్స్ అమౌంట్ అయితే గ్రేటర్ దెన్ 50,000 ఉంటుందో వాళ్ళందరినీ లిస్ట్ అవుట్ చేయండి. దట్స్ ద క్వశ్చన్. నౌ ఐఎమ్ యూజింగ్ సెలక్షన్ ఆపరేషన్. I should use selection operation. So in our system, as you don't have a direct symbol of selection operation, in our system, as we don't have a direct symbol of selection operation, I'm just using a zero hyphen. I'm just using zero hyphen. You should use the selection operation while writing in examination. You will be using the selection operation. So I'm using selection. Whose sales amount is greater than 50,000? I'm using sales amount. You can see sales amount. The heading is SAMT. SAMT greater than 50,000. Greater than 50,000 from where? From sales. I'm using sales. This is your first question. This is select. You please note down. This is a selection operation. I put it like this. Here I put a selection operation. This is a selection operation. That is selection operation. I'm going ahead with the selection operation. This is a selection operation. Select sales amount. Select sales amount. Select sales amount greater than 50,000 from sales. Your question is to display. Your question is to display the sales amount of those whose sales amount is greater than 50,000. List out all salespersons whose sales amount is greater than 50,000. Select sales amount greater than 50,000 from where? From sales. From sales. From the sales table, you need to select. Just you try to put it as a superscript like this. Select sales amount greater than 50 from sales. So you will get all rows whose sales amount is greater than 50,000. Here I wrote it as a 5,000. It is 50,000. It is 50,000. Greater than 50,000. All right. I hope so you're following how I'm writing. Your second question. List out all salespersons who are working for area north. List out all salespersons who are working for area north. Your second question. I'm using select. I'll write the symbol. Area equals to north. Area equals to n from sales. Area equals to n from sales. I'm selecting. Select area equals to n north. Generally the strings are placed in quotations. Area equals to north from sales. That is the thing. Select area equals to north. I want only rows whose from the sales, from the table sales, whose area equals to north. Select area equals to north from sales means only northern salespersons you will get. You will get only northern salespersons, not rest. So this is the query you need to specify. Select area equals to north from sales. Only the complete details of northern salespersons you will get. Select sales amount greater than 50,000. You will get all the salespersons whose sales amount is greater than 50,000. Your third one. List out all salespersons whose gender is male. I want only male salespersons. Only male salespersons I want to see. The complete data of male salesperson. So for that, what I'm doing is the third query, I'll write a selection operation here. Gender equals to male. Gender equals to male from sales. Gender equals to male from sales. Here I use the selection operation. I use the selection operation. Select gender equals to male from sales. You will get all male salespersons. Select gender equals to M. Gender equals to male from sales. You get all the male salespersons only, no female salespersons. Hope this is clear. List out all salespersons whose gender is male. So I am saying select gender equals to male from sales. Whose gender is male. Only those tuples, those rows are being selected. I am going ahead with the next query, your next query. And coming to your next query, the fourth one. List out all salespersons whose sales amount is greater than 50,000 and less than 90,000. His question is list out the salespersons, the details of all salespersons whose sales amount is between 50,000 and 90,000. Whose sales amount is between 50,000 and 90,000. List out all salespersons whose sales amount is greater than 50,000 and less than 90,000. Greater than 50,000 and less than 90,000. Greater than 50,000 and less than 90,000. I get it from one of you. Any one of you? Yeah, you please tell me. Any one of you?
Selection,
Select, okay.
sales amount
Sales amount greater than
greater than 90,000, 50,000
50,000
and less than
and operator. I should use end operator. And sales amount less than
90,000
90,000 within
from
brackets
sales.
sales. Okay. Within bracket sales. Here I am putting the selection operator. This operator, this symbol. Selection symbol. I am just putting the selection symbol. So the meaning of this is select all rows whose sales amount is greater than 50,000 and sales amount is less than 90,000 from sales. From sales. From sales. Select sales amount greater than 50,000 and sales amount less than 90,000 from sales. Only those rows whose sales amount is greater than 50,000 and 90,000 will be listed out. Rest or not. Next one. List out names and sales amounts. He is not asking all details. He want only names and sales amounts. That is projection operation. List out names and sales amounts of salespersons whose sales amount of salespersons whose sales amount of female salespersons. You want only female salespersons names and sales amounts. Only female salespersons names and sales amounts. Only female salespersons. So this is a combination of selection and projection. You observe here. Suppose if I say select, I say select, listen carefully. Select gender equals to select gender equals to female. Select gender equals to F from sales. From sales means you will get the details of all females. You get the complete details of all females. You get the complete details of all female salespersons. If I say select gender equals to F, gender equals to female of sales from sales, you get the details of all females, but I don't want the complete details of females. What he's asking only names and sales amounts. He's asking only names and sales amounts, and hence I should go with the projection operation. I'll go with the projection operation. I do a projection operation now. Now I'm going with the projection operation. I am using something like this. I want to project. The pi symbol is nothing but the projection. Project. I'm using the pi symbol. I'm using the pi symbol. Project. What you want to project? I want names and sales amounts. So yes, name, sales amount. Name and sales amount. Name and sales amount. I want only these two. Project name and sales amount from this entire stuff. From this entire stuff. From this entire stuff. Yeah. You observe here. ఇప్పుడు జాగ్రత్తగా వినండి. If you observe internal stuff, if you observe this stuff, select gender equals to female from sales means you will get the complete females details. But I don't want complete details. I want only names and sales amounts. So project name and sales amount from this complete details. Project names and sales amounts from these details. Whose details are these? Females details. From these female details, I want only names and the sales amounts. That is the query for the question 5. That is the query for question 5. You can see the question 5. List names and sales amounts of salespersons, of female salespersons, of female salespersons. So we want only female salespersons, of female salespersons, of female salespersons. Names and sales amounts of female salespersons. Let us go ahead with the sixth question. The sixth question is list out names and sales amounts of North female salespersons. List out names and sales amounts. I want names and sales amounts of North females. They should be females and they should be North area. Of North females. If you observe here, North females. Who are North females? Padma and Radha. Padma, gender is female, area is North. Radha is gender is female and area is North. What the question is, list out names and sales amounts of North female. North ayi undali, females ayi undali. North female salespersons. That is, he is asking to list out the names of Radha. Names and sales amounts of Radha and Padma because they belong to North female. Can I get from any one of you?
Sir,
Can I? Yeah, please.
project S name.
Okay, I am taking S name, project S name, sales
Sales.
amount. Okay,
Yes, amount.
okay.
Gender is F and gender is equals to female
Gender equals to female. Good.
and
And
area is equals to north.
wonderful. Area equals north.
Sales.
Sales. That's all. Okay. From north, from sales. Perfect. Okay. One more bracket. We'll close one more bracket. I'll close one more bracket. Just I close one more bracket. Okay. Let us do some adjustment. Space constraint. Okay. What I'm doing is okay, project S name, sales amount, gender equals to female and area equals to north. Gender equals to female, area equals to north. From sales, from sales, and close the bracket. Perfect. This is the perfect query. This is perfect. Select gender equals to female and area equals to north from sales. Means you will get only females north. Only females and north you will get. But I want only their names and sales amount. Don't want the complete details. I want only the names and sales amounts. And hence I am using a projection operation. Project name and sales amount only. Otherwise you will get gender, area, salesman number. You get all the details. I'm least bothered about all the details. I want only this. Right. This is the answer for your sixth query. For the sixth query, this is the answer. Dear students, you need to write down the questions as well as the answers. Students, you need to note down. I hope you are noting down. The first one, list out all salespersons whose sales amount is greater than 50,000. So select sales amount greater than 50,000. List out, select area equals to north. You will get only the details of northern salespersons. You will get gender equals to M. That is, you will get the details of only male salespersons. You get only the details of male salespersons. Here, the sales amount is greater than 50,000 and less than 90,000. And coming to this query, select name sales amount, select gender equals to female. You will get only females names and sales amounts. And coming to the sixth question, you will get only the females north who are staying in north, their names and sales amount. This is what. Let us study the seventh question. Seventh question is here. List names, area and gender of South males. He is asking name, area and gender. He want to see only names, area and gender of South males. They should be South and males. Their names, area and gender. This is what being asked. I want from any one of you.
Yes,
Yeah,
sir, project,
project, good.
yes name, comma, area,
S name, comma, area. Project, S name, comma, area. Okay.
comma, gender,
S name, comma, area, comma, gender, good. S name, comma, area, comma,
open,
gender. Area, comma,
opening
gender.
bracket,
Opening bracket.
opening bracket,
Okay, opening bracket.
sigma,
Okay.
gender,
Sigma. Okay, I'll write sigma later. Gender. Okay.
gender equal to M,
Gender equals to M. Wonderful. Gender
and
equals to
area
M.
equal to,
And
and
area
area
equals
equal to,
area equals to
yes, yes,
south. Area equals
from
to
field,
south from close the bracket and close the bracket. Wonderful, wonderful. Perfect. This is perfect. Okay. The rest of the students, you please be observing. I want names and area. Name, area, and gender. I want only these three columns. Of whom? Of South males. Of South males. So I'm saying project gender equals to select gender equals to male, area equals to South. Select gender equals to male and area equals to South. The male South. From from all male South, I want only their names, area, and gender. So this is how you need to do. The next question, your eighth question. List out the details of Gopi. Very simple. He's asking list out the details of Gopi. I want the complete details of Gopi. In this table there is a Gopi somewhere. Yeah. Here there is Gopi. One or two Gopi male north 80,000. He is asking to display the complete details of Gopi. List out the complete details of the Gopi. The question is very simple. List out the complete details of Gopi. That is the question, eighth question. List out the complete details of Gopi. You observe here, I'm using eighth question, complete details of Gopi. So I'm using selection operation. Name equals to, Gopi is nothing but name. Name equals to Gopi. Gopi from sales. From sales. You observe here, I'm using select. I'm using select. Name equals to Gopi from sales. Select. Name equals to Gopi from sales. Name equals to Gopi from sales. Select name equals to Gopi from sales. Whose name is Gopi, his complete details will be listed out. Your ninth question. List out all details of males. Similar question. List out all details of males. I want to see the details of males. The complete details of males. I'm using select. I'm using a selection operation. Selection operation because I want complete details. Gender equals to male. Gender equals to male. Your ninth question. Select gender equals to male from sales. That's all. Gender equals to male from sales. You get the complete details of males. All details of males are being projected. All details of males are projected. Select gender equals to male from sales. Complete details of males are being projected. Your 10th question. List out names and sales amounts of East females. Names and sales amounts. I want only names and sales amount of East females. East females. This is the combination of selection and projection because I want names, sales amounts only of East females. So this is the combination of projection and selection operation. Any one of you, can you help me in this solving this query? List out names and sales amounts of East females.
Projection,
Yeah.
projection, name, sales,
Projection, name,
names, comma,
name, comma,
sales,
sales amount, name, comma, sales amount,
sales amount, bracket,
name, comma, sales amount. Okay. Name, comma, sales amount.
selection,
Okay. Name, comma, sales amount. Selection. Selection.
Next, gender is equal to
Selection. Okay. Gender equals to.
female,
Okay. This is your 10th question. Sales amount. Bracket. Selection. Gender equals to.
female,
Gender equals to female. Gender equals to
And-
female. And end operator. End operator.
area is equal to east.
Area equals to east. That's all. Wonderful.
Sales.
From sales. Close the bracket and close the bracket. From the sales. That's all. Perfect. This is relational algebra. Very simple. Very simple. No complication. This is relational algebra. All these are the mathematical concepts. From these mathematical concepts, the SQL is being developed. Structured query language is being developed from the selection and projection operations. I hope this is quite comfortable. All of you. Selection, projection, end operator, or operator, relational operators, greater than, less than, greater than or equals to, less than or equals to, all these relational operators you can use and do it. Right. So with this, I would like to conclude the today's class. You just have a revision of selection and projection operators. And in my next class, I come out with some more operators of used in relational algebra like set operators, Cartesian products, difference operators, union, intersection, all this stuff of relational algebra. The other operators, division operator, multiplication operators, we will discuss that in the next class. Dear students, have a wonderful day. Please revise the topics what I explained you in this class. Thank you and bye-bye.